Welcome to math class. So we're going to start with the differentiation, and very first topic is first principle. What is first principle and what is actually the differentiation? Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find instantaneous rate of change in a function based on one of its variable, such as if you consider would like to solve a problem by the method of differentiation, say example x square. Indeed, x is the variable and we have to differentiate by a variable which is x actually. So d over dx is an operator. This is the operator of a differentiation. So we actually differentiate this function, which is x square, with respect to x. This is actually the differentiation. So what would be its value of x square? So the differentiation, we should have a operator. So this is the operator of a differentiation. And if it is x, which is the variable, top of the x is n. Indeed, the rules of this differentiation is n x n minus 1. So this is the very fundamental rule of differentiation. Now we have to start with the very first topic, that is first principle. So if it is a function f of x, let's say this is x. So function of x is equals to x is the function. Now if we use the first principle, so we could write down the first order differentiation by the use of first principle. F of x is equals to limit h tends to 0 function of x plus h minus f of x over h. So this is actually the definition of first principle of differentiation. So this is actually the whole rule. As we are differentiate x, the function, so this is the answer. This is the rule we have to follow. So what will be the final value? Let's try. So h tends to 0. And here, what is the function of fx plus h? So if it is fx is equals to x, so f of x plus h means x plus h, and f of x is equals to x. So let's plug in the x and over h. So this one cancel out, and of course in the following line, this h and this h is equals to 1. So we could write down limit h tends to 0, and here is 1. So if we, by the way, this will be 0, so the answer will be 1. So another problem, if the function f of x is equals to x square, and this time of course we are going to use the first principle for the differentiation. Indeed, by using the first order or first principle, we could write down the definition of first principle. F of x is equals to limit h tends to 0. Numerator will be f of x plus h minus f of x over h. Now limit h tends to 0 over h, and what is f of x plus h? So f of x is equals to x squared. So plug in within the x square, I mean, instead of x, we have to plug in the value of x plus h, right? So x plus h whole square, and f of x is equals to x square, same as, let's put in the value. So this is limit tends to 0 h. So this is very fundamental formula of algebra, a plus b whole square. So what we have to write, so x square plus 2x h plus square plus, pardon, this will be minus, bigger pardon. So this x square cancel out. The following line will be h tends to 0. And here, if you plug in the value of 0 in h, so what will be the result? So numerator, there is something, let's say 1, and if we plug in the value of 0 in h, so it will be infinity, which we should not attempt, right? So we can't plug in the value right now. So the fundamental policy will be cancel the h. So indeed, numerator, we common the value of h, I mean the h. So here 2x plus h and h here. So this way, this is cancel out. The following line will be limit h tends to 0, and here 2x plus h. Now the following line, if we plug in the value of h here, so what will be the result? 2x plus 0. So the final answer will be 2x, right? So the final answer will be 2x. So this is the answer for x square. This problem, determine the first principles, the gradient function for the curve. So this is the function, and obviously this function is belongs to a curve, and for x equals to 3, we have to evaluate the value as well. So let's find what is the value by using the first principle. So by the definition of first principle, f of x is equals to limit h tends to 0, and here f of x plus h plus f of x, limit h tends to 0, and here what will be the value? So f of x, so f of x is equals to 2x square minus x, and here f of x means f of x plus h. So plug in the value of x plus h instead of x. So this will be 2 and x plus h whole square and minus the value of x plus h instead of this x. So x plus h. Okay. By the way, this will be minus, beg your pardon. So this will be minus, and f of x means 2x square minus x, and obviously we have to use a bracket, otherwise we make a mistake or mess up. So please try to use the first bracket, or maybe other bracket, doesn't matter. Anyways, now the following line, limit h tends to 0, here h, and if we use the basic rule of algebra, a plus b whole square. So we could write down x square plus 2xh plus h square here minus x minus h here 2x square, and this will be plus x, right? And here will be a bracket. So this x cancel out. The following line will be limit h tends to 0. So here 2x square plus 4xh 2h square minus h minus 2x square. So x square to x square cancel out, and of course h. Now we can't plug in the value of h, otherwise it will become infinity. So let's simplify more. H tends to 0. Here if we take h as a common term, so this will be 4x plus 2h minus 1 over h. So this h, this is cancel out. Okay, let's use the different pen. So limit h tends to 0, and what left? 4x plus 2h minus 1. Now plug in the value of h in h. So the final result will be look like 4x plus 0 minus 1. So the final answer is 4x minus 1. If x equals to 3, what will be the result for the function, right? By using first order. So f of x is equals to 4x minus 1. This is our answer. Now instead of x, what we have to use? We have to use here 3, because the value of x equals to 3. So instead of 4x, what we have to plug in? 4.3 minus 1. So the final answer will be 11. So this is the final answer, or the other part of this question answer. In this problem, the function 3x square plus 2x minus 1, and the derivative, we have to use the first principle of differentiation, right? So indeed, the first principle of differentiation phenomenon, by the definition, f prime x is equals to limit h tends to 0. Here f of x plus h minus f of x and h. Now let's plug in the value of the function limit h tends to 0. So plug in the value of function of f x plus h. Instead of x, we have to plug in the value of x plus h. So 3 x plus h whole square plus 2 times x plus h, and then minus 1, and minus, let's use the curly bracket. So f of x means 3 x square plus 2x minus 1, and then curly complete, tends to h tends to 0. So limit h tends to 0. So here we have to use the algebraic formula a plus b whole square. So 3 times, let's use the first bracket. So x square plus 2xh plus h square plus 2x plus 2 of h minus 1 and minus 3x square minus 2x plus 1. So this one cancel out each other, and 2x cancel out. The following line will be limit h tends to 0. Here 3x square plus 6xh plus 3h square plus 2 of h minus 3x square. 3x square cancel out. Now the next following line will be h tends to 0. So here our main target to eliminate the h at denominator. So let's common term is h. So 6x plus 3h plus 2, and here will be h. So h's cancel out each other. Now it's time to plug in the value of 0 instead of h, because the limit is h tends to 0 indeed. So here will be 6x plus 3 times 0 plus 2. So the final result will be 3x plus 2. So this is the answer of f prime x, which is actually the derivative of the function f of x 3x square plus 2x minus 1 by using first principle of differentiation. In this problem, we have to prove that the derivative of kx cube is equals to 3kx square, where k is the constant. That is very important point. And another point, I mean the condition, we have to use the first principle. Indeed, what is the first principle of a function? So this is the function of f of x is equals to kx cube, right? So by the definition of first principle, f of x, of course the first order principle using for derivative, so here will be 1 prime. So the definition said limit h tends to 0 f of x plus h minus f of x. Now limit h tends to 0. Here of course h, and the value of the function f of x equals to kx cube, right? So k, and here function of f of x is equals to kx cube. So we have to plug in the value of x plus h. So x plus h whole cube minus f of x means kx cube. The following line now, limit h tends to 0. Here h, k, the basic equation or the rule of a plus b whole cube. So here will be x cube plus 3x square h plus 3x h square plus h cube minus k of x cube, right? So here what we have to do, we have to simplify the equation unless we can resolve the problem of h. Why I'm saying this h is a big problem here, because if we plug in the value of h is equals to 0, so the whole term will be infinity, which is not our desirable result. Indeed, we have to eliminate the term h, I mean this h. So let's simplify the equation. So this will be k x cube plus 3 x square h plus 3 x h square k plus k of h cube minus k of x cube. So this term cancel out. Limit. Now there is a common term, that is h. So let's take the h as a common part of each of the term. So this will be 3x square, and here I think k is missing, so we have to write down the k here as well. So let's write down k here, plus 3 xk and h, pardon, not yet. So this is plus, and now here k h square, and here will be h. So this one cancel out. Now limit h tends to 0. What left? 3 x square k k plus 3 x k h plus k h square. Now it's time to plug in the value of 0 instead of h. So here it will become 0, and here it will become 0 square. So this two term will be 0. What left? So the left part is 3 x square k, right? So what was our question? Our question was to find out the derivative of k x cube is 3k square k x square by using the first principle. So 3k x square. Let's see what is our result. So our result is 3 x square k, or we could write down 3k x square. So proved. In this problem, determine from the first principle to find the gradient function. So the gradient function y is equals to 1 by x, or this function can be written as, say, function of x is equals to 1 by x. So y equal to 1 by x or f of x equals to 1 by x, the same meaning. So by using the first principle, we could write down differentiation of this function. Limit s tends to 0. Here h, f of x plus h minus f of x, right? Limit h tends to 0. Here h, so the value of f of x plus h. So here the function f of x is equals to 1 by x. So we could write down 1 by x plus h minus 1 by x. Now what I can do here, multiply with x by x, and here x plus h over x plus h. Why? Here we have to write down limit h tends to 0. here h. So why we have done this? Because we have a common numerator for the both term within this function. So we actually have the LCM will be x of x plus h. So we could write down x minus x, and plus minus it will be minus h. So this x cancel out each other. So limit h tends to 0 h, and here numerator will be x plus h, and here minus h left. So this h cancel out. Now the following line, of course, limit h tends to 0. Now how it's look like? So this is minus 1 by x. Now if we plug in the value instead of h, so we won't find the value of infinity, so we could plug in here. As a result, we should not write down this limit within this line. So when we plug in the value of 0 here, or value of 0 instead h, so in that line we should not write down the limit. And here the final answer will be minus 1 by x squared. So this is the answer. Another practice case, let's say the function y of equals to x cube. Now, by using the first principle, we could write down f of x differentiation, first order differentiation. F of x is equals to limit h tends to 0, here h, and function of x plus h minus f of x. This is the definition. Now plug in the value, limit h tends to 0, and here h, and as this is the function y is equals to x cube, now we have to write down instead of x, it is x plus h. So it will be x plus h whole cube minus f of x means x cube. So let's write down the value of x cube. Now again, we have to write down limit h tends to 0 until unless we are plugging the value of s is 0, and we should not write down the value of h tends to 0 where we find the value is infinity or 0 by 0 order. So let's simplify. So x plus h whole cube, basic algebra. So x cube plus 3 x square h plus 3 x h square plus h cube minus x cube. So x cube cancel out h. So the following line will be, of course, limit h tends to 0, and here at denominator h is common in every term, so let's common h is a common part from each of the terms. So this is 3 x square plus 3x h plus square, and here h. Why? Because we have to cancel out this h at the denominator, so there will be no infinity we found. So the major task have done. So now it's time to plug in the value of h tends to 0. Why we are plugging here? Because if we plug in here, so there will some absolute value we find. So this is 3x square plus 3x dot 0 plus 0 square. So the value will be 3x square. So this is the answer. So in this example, we have a function f of x is equals to 3x square plus 2x. By using the first order or first principle, so by using first principle, we could write down the first order differentiation of f of x is equals to limit h tends to 0 f of x plus h minus f of x, limit h tends to 0, and here the function f of x plus h. So let's plug in the value of x plus h instead of x. So here 3x plus h whole square plus 2 times x plus h minus, let's use the first bracket. So the function of fx means 3x square plus 2x, and of course here h. So the following line will be limit h tends to 0, and the basic algebraic formula will be a square plus b square. So x square plus 2xh plus h square, bracket close, then plus, so 2x plus 2h minus 3x square minus 2x, right? So this 2x and this 2x cancel out, and here will be h. Afterward, limit h tends to 0. Here h 3x square plus 6xh plus 3h square plus 2h minus 3x square. So this 3x square, this 3x square cancel out. Now it's time to do more simplification. So we have to common h from this 3 terms. So if it is h, so it will be 6x plus 3h plus 2, and of course here the 2h. So h is cancel out. Now if we plug in the value of 0 at h, so it won't be infinity or 0 by 0 order. So we could plug in the value of 0 instead of h. So 6x plus 3 dot 0 plus 2. So we could write down 6x plus 2. So this is the final answer. So the derivative of the function is fx is equals to x over x plus 1. So the function is this one, and the condition, we have to use the first principle of differentiation. So the first principle of differentiation for f of x prime, limit h tends to 0. I mean by the definition of the first principle of differentiation of any function. So that function's first order differentiation is equals to limit h tends to 0 f of x plus h minus f of x over h. Now the function is x over x plus 1, so limit h tends to 0, so it will be x plus h as the function of x plus h. That's why plug in instead of x will be x plus h over x plus h plus 1 minus x over x plus 1 h. So h tends to 0. Here the LCM will be x plus h plus 1 times x plus 1. Here x plus h times x plus 1 minus x times x plus h plus 1 over h. Limit h tends to 0. So here will be h and here will be okay. So it will be x plus h plus 1 times, and if we multiply, so the result will be x square plus xh plus h plus minus xh minus x. So let's use the different color pen. So minus x square cancel out, xh cancel out, this one and this one cancel out as well. So we have, so it will be limit h tends to 0. So here will be x plus h plus 1 times x plus 1. Here it will be h, just h left here, and here will be h as well. We know that a by b over b by c. So here b by c is this h, and here a is h and b is this two terms or two factors. So if we simplify this one, limit h tends to 0, so that we could write down h over x plus h plus 1 and then x plus 1, and this h will be here. So h is cancel out, so we could write down limit h tends to 0, 1 x plus h plus 1 and x plus 1. Now this is the right time to plug in the value of h is equals to 0. So 1, here x plus 1 and here x plus 1, as h is equals to 0. So we could write down 1 over x plus 1 whole square. So this is the final answer. So this problem, find out the derivative function f of x equals to sine x using the first principle of differentiation, right? So the function is sine x. By using the first principle of differentiation, we could write down f of x is equals to limit h tends to 0, f of x plus h minus f of x. And of course here h, this is the definition of first principle of differentiation. So limit h tends to 0. F of x is sine x, so f of x plus h means sine of x plus h minus sine of x over h. Now if we plug in the value of h is equals to 0, so it will become infinity. We should not go for this direction. So what else we have to do? We have to simplify the equation. So this is 0. Now we can do one thing, that sine x plus h minus sine x. This is actually a trigonometric function. So we know the basic equation of trigonometry, that is sine A minus sine B. So let's write down here sine A minus sine B equals to 2 of cos A plus B over 2 dot sine A minus B over 2. So this is the equation, right? So here sine A means x plus h, B means x. So this is actually A and this is actually B. So the equation will be 2 of cos A means x plus h plus B means x over 2 dot sine A means x plus h minus x over 2, and here will be h. Now limit h tends to 0. So here will be 2 cos 2x plus h over 2, and sine this x cancel out, so this will be h by 2 and this will be h. Now limit h tends to 0. So here we could write down limit h tends to 0. Okay. So if we could write down sine h by 2 over this h here, and this 2 we could write down here. Which formula? We know a by b over c by d. Here c by d means h and here ab means 2. So we could write down in the following line that so this is, let's say, p and this is q. So we could write down p over q, right? And limit h tends to 0 cos 2x plus h over 2. Or maybe we could write down that x plus h by 2, same thing, right? Why I have written this part? Because trigonometry, we have a rule, limit theta tends to 0 and sine theta over theta is equals to 1. So we could write down here 1. Okay, let's use a different pen. So this is 1. So this whole value is 1, right? This is a basic trigonometric equation or trigonometric rule. And now limit h tends to 0. Now if we plug in the value of 0 instead h, so this term will be 0. And what we left? We left cos x. So cos of x is the final answer. Find the derivative of sine of x where x is equals to 0. So the condition is we have to use the first principle of differentiation. So the function fx is equals to, so fx is equals to sine x, and the condition is we have to use the first principle of differentiation. So indeed, when we are using first principle of differentiation, so first principle of differentiation is equals to limit h tends to 0, here h, and f of x plus h plus it will be minus f of x. Here the condition x is equals to 0. So at x is equals to 0, so first principle of differentiation f of x prime is equals to limit h tends to 0. So here f of, plug in the value of x equals to 0 plus h minus f of 0 over h. Now limit h tends to 0, f of h over h so limit h tends to 0 over, so f of h, the function is sine, so let's plug in the value of sine of h over h. We know that limit theta tends to 0, sine theta over theta is equals to 1. So we can write down here 1. So this is the answer, because limit h tends to 0 and sine h over h. So this is the formula of first principle of differentiation. Limit theta tends to 0, theta over theta is equals to 1. So here are same, so the answer will be 1. So the function is f of x is equals to tan x. So by using first principle of differentiation, so f of x prime is equals to limit h tends to 0. So this is the definition of first principle of differentiation, f of x plus h minus f of x over h. Limit h tends to 0, and f of x plus h means tan x plus h minus tan of x over h. So limit h tends to 0. Here we could use the formula of 10a plus b. 10a plus b is equals to, we could write down 10x plus 10h over 1 minus 10 of x 10 of h minus 10 of x and h. So limit h tends to 0, and here what will be the LCM? So the LCM will be 1 minus 10 of x 10 of h, and here 10 of x plus 10 of h minus 10 of x times the value of LCM, so 1 minus 10x and 10 of h over h. Now what we can do, here will be limit h tends to 0. Could write down, rearrange the equation like 1 minus 10 of x 10 of h, and here will be 10 of x 10 of h minus 10 of x, and this minus will be plus, and 10 square x dot 10h, pardon, this will be 10h, right? Okay, so limit h tends to 0. Here what you can write down, so here I think made a mistake, here should be plus, right? So this 10x cancel out, so here we could write down 10 of h common term, so 1 plus 10 square x over h 1 minus 10x and 10 of h, right? And here what we can do, we can separate like limit h tends to 0, and we could separate this part, and also we could write down tends to 0, so 1 plus 10 square x 1 minus 10x and 10 of h. So as we know that limit theta tends to 0, then theta tends to 0, limit theta tends to 0, and tan theta over theta is equals to 1. This is the basic rule of first principle of differentiation. So this will be 1, and here we plug in the value of h is equals to 0 in h, so 1 plus 10 square x and 1 minus 10x dot 0. So we could write down 1 plus 10 square x. And by the formula of trigonometry, we know that sec squared theta minus tan squared theta is equals to 1, or sec squared theta is equals to 1 plus tan squared theta. So we could write down here sec squared theta. So this is the final answer.